AlphaGo is a um, AlphaGo is a computer program developed by Google DeepMind to play the board game Go. Go is a strategy board game for two players in which the opponent wins by claiming more territory than than the player. It is a 19 by 19 in size board uh, uh, which uses the black and white coins to mark the territory. AlphaGo was the first computer program to defeat a professional Go player without handicap and a full-size board. The development process of the AlphaGo involved the using of deep neural networks and research. Coming to the data used in the AlphaGo of, for all the previous version was from a human expert moves, which was used in supervised learning, as well as rollout policy, which was used in the earlier versions of deterministic machine learning model. The rollout policy uses 13 million positions from the KGS Go server as the input. The 13 million positions are the 19 by 19 in positions. The reinforcement learning policy network uses self-play positions, which means it plays against itself to maximize the outcomes of the. Coming to the features, every state of uh, the current state can be is represented in the AlphaGo in the form of a 19 by 19 into crossed 48 three-dimensional matrix, whereas each plane or multiple planes are used to represent features such as tone, color, and such as libraries and different things which are uh, collected as features, and each feature represents some part of the state, and all these features are evaluated and put them as input for the neural network to receive an output. Coming to the training process, the training process, there are two major distributions in this process. That one is policy network, and the other is the value network. Coming to the policy network, the two are these both are two neural networks, that is convolutional neural network, and these use Monte Carlo tree search and also convolutional neural networks to analyze the thing. Uh, for the Coming to the policy network is use the probability of an action and from the current state. For example, the probability of this green dot out in the Go matrix X has the probability of 0.60, uh, which is the probability of the Go matrix of the next action, which is probably taken by the player. The output of the policy network is a 19 by 19 matrix, in which each value defines the probability of the action from the current state. The policy function is a crucial component of AlphaGo decision-making process, allowing it to make select moves that are likely to lead a win. Uh, and also in this AlphaGo, even though the probability of this position is highest, the policy network includes sometimes noise, so that the not only the highest probable places are taken, so that it leaves gap for exploration, and uh, rather than being a greedy search for this. Coming to the value network is given for the current state, and the value of this state, it is the value of the given state is analyzed by how many times this current state is present in the training trajectory. Like if this position, if a user gets to this current state, and the probability of the player winning this game M is determined by the value network. Okay. Coming to the visual representation of the policy network, the network has this uh, has the probabilities of each position, and having the the probability of the each position, and the positions having the uh, probability of each position. And coming to the value network, it's a single value for theta, and this value gives how many times, like how many this value provides the information regarding how many times this current state leads to the winning trajectory. And AlphaGo uses Monte Carlo tree search to reduce the search tree by selecting the maximum value action edge in the network. Um, uh, like depend from the previous position, from the previous thing, and consider that um, the current action to the uh, a probable outcome, high result value. Then the other other things are other moves are ignored, thereby reducing the search tree into a smaller search space, so that it can be easily evaluated. But also this also includes a noise of 0.25 0.25, like 25% of noise, so that all the exploration part is also not neglected. Coming to the Monte Carlo tree search, Monte Carlo tree search is a search tree where there are four types of selection process. In this, the one is selection, where you'll select the maximum probability, and the other is exploration. Exploration is where you don't select the maximum probability and go to a random position. And evaluation is going after the going through the uh, selected output, and while backup is from selecting the output and going backtracking through the uh, selected outputs. Coming to the reinforcement learning, the in this AlphaGo, the game plays against itself, and to generate data instead of relying on the human data. Like instead of relying on the human data, which is difficult to calculate, and also difficult to manage and understand. Uh, the game plays against itself and analyzes each position and each state of the matrix, and each state of the game, and to give a position, or like give give the probable output for the value network and the policy networks. For example, the first 30 moves, the temperature, the rate of moves is set to 1. And to encourage exploration, so that for the 30 moves, the exploration part is still there, and the remainder of the game, the temperature is set to 0. This method also adds a little bit of noise, that is 0.25% of noise, so that the system can also explore its territory rather than sticking to the highest probable thing. This noise is called Dirichlet noise. Uh, to the prior to the further encouragement of exploration. The probability of probability of the current action A, taking this action A from the current state, is equal to 1 minus the probability of action A plus the noise factor, which is 0.03 included with action A. Yeah. Coming to the summary, the AlphaGo and AlphaGo Zero use reinforcement learning and different convolutional neural network to predict the outcome of the game. The use of Monte Carlo research decreased the search space from seemingly impossible numbers such as 10 power 86, which is almost equivalent to the number of atoms in the universe, to a small computationally feasible value to estimate uh, to give a model. Thank you.